Welcome back, welcome back, welcome back. I'm Miss Lisa. This is my YouTube channel where we talk about math and science. We are going to do heat problems, thermal energy problems. This is physics class, and we're going to be working through some problems in a book that you can do these problems or you can do different problems. These are good example problems, but this is a class and we're working through a book. And if you want to know what book it is, go back and find the introduction video to physics, and it should have the ISBN number if you want to join and work through these problems with us. All right, so our first example problem says, I'll read it out loud. You can read silently. It says convert 25 degrees to kelvins. Well, we need our formula, and Kelvin is equal to Celsius degrees plus 273.15. Some books don't bother with the 0.15. Sometimes they just do 273. So now we substitute what we know, 25 underneath Celsius degrees. 273.15 is still it. We add them up and it's 298 Kelvin. And if you're taking this class, this is like number 1 on the test in this chapter. Okay, for the math problems. So now number 2, convert the boiling point of helium, 4.22 Kelvin, to degrees Celsius. So we want to convert 4.22 Kelvin to Celsius. Our formula, I probably should have written it down again. Here, let me write it right here. My formula is Kelvin equals Celsius plus 273.15. So now I'm going to substitute what I know into this formula. So underneath Kelvin, I write 4.22 Kelvin. Celsius is my unknown. 273.15 is my known. Why is Celsius not alone? It's being added. It has 273.15 added to it, so I do the opposite. That's how you solve for a variable if you have an equal sign. So I do the opposite, which is subtract, and what I do to one side, I do to the other. These cancel out, and 4.22 Kelvin minus 273.15 is 268.93 Celsius. All right, that one was easy too, wasn't it? I'm not even going to bother showing it to you on my calculator. You can do that. Okay, here's number 3. A 400 block of iron. So you know we first write our knowns and unknowns. 0.4 kilograms. Also that it's iron. Iron matters because we are going to need its specific heat, and we're going to look at this chart to find it. See, iron is 450. Iron 450. So I'm going to write that down too. The iron is heated from 295 Kelvin to 325 Kelvin. So I have two temperatures, 295 and 325. I know my formula is heat equals cat, mass times the specific heat times the change in temperature. So I'm going to need the change in temperature. So I just go ahead and do that. 325 minus 295 is 30 Kelvin. That's what my change in temperature was. Okay, and then it says how much heat is absorbed. So heat's what I'm looking for, Q, and the formula is cat. So now I substituted in 0.4 for mass, 450 for the specific heat of iron, and the change in temperature is 30. You get on your calculator, it's 55,400 joules. Your book wrote it in scientific notation. I think they unnecessarily do that. You can imagine the number 5,400, but 5.4 times 10 to the third is just hard to imagine what it is. So I'm all for leaving it not in scientific notation. Your book does it because of significant figures. All right, problem number 4. A 500 kilogram sample of water. So I'm going to list the mass of water is 0.5 kilogram. The specific heat of water is 4,180. So that's why I got that off the chart. Is at 15 degrees Celsius. So I got the temperature of water is 15 degrees Celsius. Is put in a calorimeter. A 0.4 kilogram block of zinc. So 0.4 kilogram is zinc, and the specific heat of zinc off of that same chart is 388. Is placed in the water. Find the temperature of the system. So we got to find our temperature final here, and they tell us the specific heat of zinc is 388. So that's always going to be given to you, or it'll be in a chart. You have to look it up. Okay, so here are our ideas. Our ideas is that the final temperature for both the water and the zinc is going to be the same thing. And the heat gained by one is lost by the other. So the water is going to lose heat. The zinc is going to lose heat. The water is going to gain it. One is negative MCAT and the other one is positive. Now the way your book does is they kind of solve for it, and I think that's terrible. I don't like the work that way. I like to set it up like this: that my A is going to lose heat and my B is going to gain heat. That one loses heat, the other one gains heat. So I'm going to put a negative on this one, and it is 0.5 times 480. So this is my water. And then the final the change in temperature is final minus initial, and I don't know what final is. And then on the other side, here's my zinc, the mass of zinc, the specific heat. The temperature final is going to be the same, and then minus 115, the temperature of the zinc there. Now I'm going to start getting it together. I'm going to multiply negative 0.5 times 480 and get this. 0.4 times 388 and get that. Now I'm going to use the distributive property. Remember that from Algebra 1? And I'm going to multiply negative 290 times temperature F and get that. And negative 290 times negative 15 and get that. Then over here I'm going to use the distributive property again. 15.52 times TF and get that. 15.52 times negative 115 and get that. Now I gather up my terms. When I teach math, I sing a song here. It goes like this: gathering up your terms. So that means you can't add or subtract things unless they have the same letters with the same exponents. So first, I'm going to make the numbers go on this side. So this has a negative 1784.8. So I'm going to add 1784.8 to both sides. These will cancel out, and then those added together is that number right there. Now I'm going to move this one the other way. So the opposite of minus is plus. So I do plus 2090 TF to this side and to that 1552, and I get this 2105.52 TFs. Why is TF not alone? It's being multiplied by this, so I do the opposite. I divide both sides by that. These cancel out, and the answer is 15.74 is TF. I go over here and check it, and yay, 15.7, and that would be a Celsius degrees. All right, that one was fun. Let's do another one. Here's number 5. Okay, number 5 is about the heat of fusion, that chart that I drew on the board in the other video, in the concept video. Okay, it says, if 5 times 10 to the third joules, did we really have to do that? Couldn't we have said 5,000? Is added to ice. So my heat is 5 times 10 to the third. It's ice. And so I look up on the chart, and the heat of fusion of ice is this, of water, 3.34 times 10 to the fifth. And they ask us how much ice is melted. They want the mass. What's the mass? Well, this is our formula. The heat is equal to mass times the heat of fusion. So the heat they gave me, the mass is what I'm solving for. That's the heat of fusion. Why is m not alone? It's being multiplied by this, so I divide both sides by that. So 5 times 10 to the third divided by 3.34 times 10 to the fifth is that. And let me just show you, just in case you've missed the other videos and you don't know how to put these numbers in your calculator. Let me clear out what's in there. So you turn on your calculator here, and we're going to put this first number in there. 5 times 10 to the third. You do 5, and then you do second comma. See that EE? It puts an E right there. That means times 10, and I want it to be to the third power, and I say 3. You don't do up arrow. It looks just like that. Now I say divided by, and I'm going to do my other number, 3.34. And now I do second comma for the EE. That means times 10, and it's the fifth power. Enter, and there it is, 0.01497, and they rounded it off to 0.015 kilograms. All right, last problem, number 6. It says, how much heat, so we're looking for heat, how much heat must be transferred to 100 grams of ice. So I have a mass of 100 grams, but you notice all of these things have been in kilograms. So I'm going to move my decimal point over 3 times and make it 0.1 kilogram. How much must be transferred to 100 grams of ice at 0 degrees Celsius? So I've got ice at 0 degrees Celsius. Until the ice melts and the temperature resulting water goes to 20. So I have 2 temperatures. I've got the heat of fusion of water that I looked up. I've got the specific heat of water that I looked up. And I'm going to have to use 2 formulas. First, I need to get the heat of this. So I do the mass times the heat of fusion, and I get that heat. Then I do the heat equals cat, mass times specific heat times change in temperature. The mass is 1. That's the specific heat. That's the change in temperature, and I get that. And for the total, you add them up. So it's exactly where all this came from. You can read more about, but you just add them up, and there's the answer. And it's the heat it took to go that the water gave to the ice and melted it. All right, so that's it. I think these are pretty fun. They're a little hard, and hard math's fun because it's fancy math, right? So math is great, science is great, and physics is great. Like, share, subscribe, and I'll see you for Chapter 13.